It's very good to be here again. I mean, the first time I was here was in 1992. Not here, but in Ministerial Belo Horizonte. And a little joke was that I set up a computer lab there for them to do simulation and other things. At that time, I was a lecturer, young lecturer at Sheffield. So I was invited to Belo Horizonte to set up a lab. And then I was busy working one afternoon, and all the students came and saw me working very hard and told me I should not be too worried about the next day's lecture. And then some of them told me that they will bring something, medicine, that I can take, that I will be very happy from then on. So I said, okay, okay. So next day, a few of them brought a bottle of cachaça and put it there. I said, drink it and you will be very happy. I drank some of them, and I'm not too sure what I was talking about at that time. So no cachaça today, yes? Okay, in that case, we can talk something more serious. I gave a lecture a few days ago in Karin's conference. Some of the slides will repeat, but then I also have some other messages. Because today I would like to talk a little bit about how we work with administration. A lot of the time academics are not very good at working with administration. Therefore, our findings and our discoveries are normally not used. And that's a pity, because we know a lot about how to solve the problem. But most of the time we cannot communicate. We don't know how to communicate with the administrator. So our results are only confined in academic world and not be too useful for people who are outside living. So this is the first slide. On the right, on one side, a lot of the city planners will draw this kind of diagram to show how nice a city should be or will be. On the other side, the meteorologist always tell you the problem of the city in another way. In this particular case, pollution problem, and we are dealing with the same thing, but we have different kind of what we call language, and this is the most fundamental problem when we work with people like them. Oh, okay. How many of you can read this diagram and understand every arrows, every symbols on this diagram? I guess not many of you, okay? If you can understand a few things, it will be good. Cold front, warm front, also the pressure difference and things like that. This is the kind of diagram that meteorologists draw every day. And and they understand how everything moves around: air, pollution, cloud, pressure systems, temperature, everything. So they use this diagram, and we architects and planners don't understand them. But then in another situation, when I talk to meteorologists, I'm an advisor to the Hong Kong Observatory and also WMO. And I told them, how many of you meteorologists can understand this particular diagram? None of them could. But if a planner in Hong Kong were to be presented with this diagram, he knows exactly how the city looks like, where it is going to be developed, what are the useful spaces, what are the amenities, how high the building should be, and what are the zoning and usage and everything else. So planners also use diagram like this to signify what the city looks like. But meteorologists cannot understand this. And therefore, they cannot comment on whether or not this is good enough for the city from an environmental point of view. So we speak different kind of language. And that has always been the problem when we work in a cross-disciplinary manner. Okay, London used to be like that once upon a time before I was born. You probably can remember this from pictures and books of what 19th century London looked like. They have their own high density problem. By the way, London became so-called high density, very high density, by the end of the Industrial Revolution. Not high rise, but high density. You can have a very high density city without going high rise. Mumbai today is one example. I'm quite sure here as well. So there are what we call the two-dimension high density living that you can practice. And London was an example. And they have a lot of problem. And at that time, a book was written to indicate that there is something called urban heat island. This is the first book that capture that in the city, the temperature is very different from the outside. And this is the first diagram showing the small difference in terms of temperature and the higher difference in terms of temperature at night. So this book, The Climate of London, in a way written by somebody called Luke Howard, signify that in cities, the climate is different. But he has no understanding of how it happened. Okay, so that was the first book that was published. Almost at the same time, this other Howard, Ebenezer Howard, published another book called The Garden City. I'm not too sure whether or not they are friends, but both are Howard. They're not brothers. They're just Howard, okay? And he published this book. And in this particular book, he talked about the future of our city, how our city should be like, not try to address the problem of London high-density environment. But in this particular book, he mentioned garden cities of tomorrow, i.e. people should live in a garden situation. He was not trying to address the problem from a density point of view. He was just trying to make sure that the problem does not continue if London were to be redeveloped. So with this book, of course, the London government changed the way that they planned at the entire city by putting green belt outside their city, and also to put satellite cities very far away from the core city and link it back by transport into the city. That becomes the kind of town planning model of the 20th century in a certain way. And it all starts with this book. And in this particular book, he talks about different kind of reform, different kind of structure. And also he talked very much on how the environment, fresh air, sunlight, and things like that should be enjoyed by city dwellers. And all these things, I'm not too sure when I look at it that he has some idea of what Luke published a little bit earlier on the climate of city. But these two books somehow set the kind of relationship in a way between climate and city planning. And you probably know this city plan by him, Welling Garden City. I actually studied in this city for a year before I go to university. And you can see how the zonings and also the interesting features of how greening should be integrated into the city was planned. The most important thing is the undulation of the parameters, this kind of thing. And also the axis that actually go through the entire city with public amenities, but also very low density kind of development. This is what they call the green corridor of the city. And the rest of it just undulate. So already Ebenezer Howard understand how to avoid the problem of a kind of urban heat island kind of a city layout by proposing something a little bit more better in terms of urban climate. But he, at that time, of course, did not know the science behind it. He was just trying to use his common sense to see how whole things should go. Now, a lot of the time, therefore, when I talk to planners, I told them to go to the observatory and understand what climatologists are talking about and kind of language they use. And also, when I talk to climatologists, I ask them to go to the planner meetings to understand what planners were talking about. So you all have to organize a lot of this kind of cross-disciplinary, not meetings, but drink parties. Yes, because when people drink, they are very happy and they try to understand what the other guys were talking about. Otherwise, they sit and they don't do too much. And many times that we have this kind of diverse opinion and also problem. So when you come to the town planning board meeting or whatever, then if an environmentalist say something, the planner doesn't like it. and say this is rubbish. Now, an example is this. A long time ago, the climatologist presented this diagram to a high-level minister. He said, in cities we have urban heat island, therefore we calculate that the city is going to be 3 degrees higher than the surrounding area, so we should do something about the city. So do you know what the minister suddenly say? He looked at it, he say, okay, what can I do? Should I therefore not build the city, or should I therefore demolish the whole thing? What should I do? This is a natural phenomenon. Therefore, so the climatologists say, but cities are hotter. Yes, so what should I do? They offer very little advice. And actually, if you look at it from a physics point of view, from average kind of temperature, layout, distribution point of view, there is no solution, because the city, because of its own structure, obviously, anytime, whatever you do is going to be hotter. So you can't do anything. There is no solution. However, when I look at this particular diagram by, I think it's by James Oak and other people, I look at it, I suddenly realize that if the climatologists present to the planner this diagram instead of that diagram, a lot can be done. The difference is we are not talking about the average of everything, because there is no way to solve the average problem of a city. The city is going to be on average hotter anyway. However, there are a lot of opportunities to solve the diverse kind of places of the city in many different ways. So the overall kind of curve is not going to be important. It's this kind of dip, little dip. Okay. Now this next question is, where are they? How good are they? And how frequent are they? How big are they? Then it defines the city, because you will therefore create in the city many different opportunities for improving the city. These are the problems that you will have. So you don't improve those problems, but you try to divert your people to this kind of solutions. And then a lot can be done. Transport can be optimized, the building form can be optimized, the open space distribution and frequency and then density, and also the size can be optimized. A lot of things can be done, especially during daytime when people are working. Nighttime, a little bit more difficult, okay? But nighttime people don't go out that frequently, and by the way, nighttime is cooler anyway. So you only need to solve this problem. And this problem can be solved, and there are a lot of opportunities. So based on this understanding, we can therefore tell the city planner, this is the thermal image of Hong Kong surface temperature, and the most important thing to tell the policymaker is that, okay, where are the problems? When the colors group together in big chunk, i.e. people cannot escape or find ways to relax, then there is a problem. However, if you go to this area, for example, yes, there are a little bit of the problem, but there are many other dips. Even this area here, you can find the dips punctuating the hot zone. So the problem there is very different from that problem or even that problem there. So the idea is therefore for the planners to say, okay, what can we do to this so that it becomes something like that. And there people can choose where to go in short distance apart. So things can be done. Planners can do a lot of things, and each district council then look at their own district, for example this district, and say how to avoid the problem that will result if you design not properly. But on the other hand, some districts say, okay, how should we solve this problem? I will show you an examples of how we therefore help the governments to solve this particular problem. This is 1 kilometer by 1 kilometer. So if you run from one side to the other side, you'll be dead before you get to the other side, if the climate was too hot on that day. So this particular professor was very interesting because she was the first, I would say, first professor who tried to ask the question why we are not using knowledge properly in our planning system, or what kind of knowledge system we need for our planning that the climatologist does not give us. So he argued a number of a framework to try to understand why the two groups does not talk to each other. And he identified a number of problems and defined this particular wonderful framework that our conceptual thinking is different and our technicality, our models are very different. And there are other things that are so different that because of those things, you cannot talk to each other. You don't know how to talk to each other. And some of the things can be done to solve this problem. For example, if we can find a common language that we both work together in terms of the knowledge, then it will become easier. So this was the first paper, actually, as far as I know, talk about how the two groups of people, planner and climatologists, can somehow find ways to work together by addressing the differences in terms of conceptual all the way to institutional. This is another paper that I think is also very useful. It's a paper presented to WCC3, which is a very important conference to the climatologists, telling them that actually we planner needs some information in a certain way. And therefore, whatever you're trying to give us must somehow conform to those information formats. Otherwise, it won't be too useful. Lately, I think this year, WMO just published a climate service for urban area guideline for all the observatory in the world to follow in order to give information for planners or for city people. In the past, you know, the climatologists, people only worry about shipping, okay, farmers, and people who are outside, fishermen. But now they want to give information to city planners and city dwellers. They all know that this is more difficult than in the past, because in the past they only need to set up 2 stations, one in the park somewhere and one at the airport, and that's it. But now they need to set up stations inside the city, and they ask where. My answer to that where is how many. So in Hong Kong, for example, we used to have 40 stations around Hong Kong area. But then when they try to come into the city, in one district, they put in 200 stations, because with only 200 in one area, in this area, 200. We have this in this particular, this is about 2 kilometers by 2 kilometers. So I told them that if you don't put in 200 in that area, you don't know that area at all. Because it is not where that is important, it is how many, because the city is by nature of its structure inhomogeneous. And you have to capture that inhomogeneity rather than the one number that represents the area. And that is a completely new kind of concept to them, because when they set up a station, you know that they have a definition of a piece of grass and other things. I say, no, you just need a lamppost. They say, that won't give you the good representative kind of reading. I say, no, you don't want something representative. You want the whole picture. So this becoming something new mindset for them. And at the moment, the government, Hong Kong, is now putting thousands in the entire city, literally thousands. But nowadays, the stations are very cheap. You only need a sensor and a remote Wi-Fi or something like that. You have a station. So they're pumping in a little bit of money to put in 2,000. And it doesn't really matter where. It's just a matter of covering the ground. Anyway, so this particular paper actually tells them the capability, i.e. what we know, and then the needs. These are 2 wonderful papers that you should read and you should cite, because my name's there. So you improve my citation a little bit. But then I strongly recommend that this, I think these 2 papers set out the fundamentals for the climatologist to look into the urban area. In the ARC, AR6, the next IPCC report called AR6, there will be a big chapter on urban climate and urban city design, a big chapter. One of those who write it will be one of my students, Charles. She's now a contributing author. and she asked me how much she can write. I say as much as you want, because IPCC reports are this thick, so it will be good, okay? And in that two papers, a number of issues are identified. I'm not going to go into that, but then it identifies something. And that paper was published by Gerard Mill, one of the key authors of those two papers, about how we can see urban climate in urban planning and vice versa. And this particular paper is almost at the same time. It was about how they applied to an environment. I think more of that is in the climate book that you have bought. Thank you. Every time you buy that book, I have a few dollars in my pocket. So I get richer every time you do that. So do that more often and do that every day. And that would be very good. Okay, thank you. They're trying to promote a common platform of using a map-based information platform so that the two groups can come together. Remember, the two groups use different kind of map. If that map can be understood by both groups, then the chances of communication will be much higher. So that was the thesis behind this particular paper, and of course, behind the book that we subsequently put together. This paper you must cite, a very, very important paper, okay, by somebody whose surname cannot be pronounced. I was trying to argue in that paper that actually the climatologist or this engineer does not need to give planner too many information. They only need to say two things, okay, because it won't take too long for you to say two things very concisely. One is how often it happens and how much problem it will cost. If you tell the politician, okay, somebody will die every day and all your constituency people, half of them will die tomorrow. Okay, that's every day or tomorrow and half of them. He's going to listen. Okay? If, however, you talk to them about probability and area and all these other funny ratio and things like that, he lost interest. So you only need to know how often it happens and how difficult it will become when it happens. So when we construct our information, we only need to state the most, what we call prevailing situation. Forget about in the afternoon 3 o'clock, something else will happen. That kind of nitty-gritty, he doesn't want to know. So my argument was to construct an information platform that only stick to these two fundamental principles, how often and how much impact. Then the information platform will be very focused, okay? And the policymaker will listen. And I will show you later. So this is again, Gerard Mills also kind of agree with that kind of understanding. He called it the general pattern and the critical issues. That's the way that he called it. I called it using another two words. But the concept is very simple and similar. Then we look at some of the observatory systems in the world. We found that actually the best at that time was in Berlin, that they try to not only capture the data, but demonstrate it in a more what we call the user-friendly way. They basically tell you how you feel rather than what is the temperature. Okay, and therefore once you feel that way, this is what you should do. So the information platform is a little bit more friendly, or I say this climate service that they provide is a little bit more friendly to people who are experiencing the city. Now, for those of you who are into urban planning and climate, I must alert you with the wonderful things that Stuttgart, the city of Stuttgart, did to address the relationship between climate and city. And this is, I think, still their website showing a lot of the information that you should know. And therefore, they actually are one of the first cities in the world, very early on, put together the mapping system. The maps were done by climatologists. But then it will then translated by planners under the recommendations of the climatologists to become planning guidelines. So the climatologists tell them in different parts of the city, the environment behaves differently. And with that difference, the understanding was A and B and C, and therefore the planning should be something else, X, Y, Z. So they put together climate analyzed map, and then using that, they talk to the planners and put together the recommendation map. The good thing about how they work together is that the climatologists are actually inside the environmental planning department. They are part of it. They are not separate. They are not different kind of people. They work together. So they have a higher chance of success because of the fact that they work together. And based on that, their earlier work, then Chow, my student, put together a review paper. It's very highly cited at the moment. To capture the 40 years of development of this kind of methodology so that the two groups can work together. I mean, for many years, 30 years or so, Germany was the only country who practiced it. And then suddenly the Japanese researcher find out that they are doing something useful for Tokyo. And now we in Hong Kong find that it is also useful for China. So, so these are the few areas that we have been trying to use this methodology. And these are the few maps that we put together. A joke that I can tell you is that you know that when you put a map together, you signify different characteristics by using different color, yeah? That's typically how maps or colorful maps are made. And so the red areas are problematic area and the green area are nice areas. So if you know that you're living somewhere near here, then your house is going to, the price of your house is going to increase. Things like that. So every area, this is actually in Arnhem, in Netherlands. They have problem. They also have problem areas, even if when the density is small. And then this map is the only map that does not have red. Because when we present the map to Singapore government, Singapore government being Singapore government, they don't want people to know that some of their city is not very good. So they say, would you mind change the color a little bit? So all the red color become pink. There is no red color, okay? It's no problem. That's how they look at it. So the Singapore map is the only one that without red color. I won't be allowed to go there now. Oops. These are the few books that I think I just signed one copy. Chow actually put together a Chinese version, and this book is 10 times cheaper than this. So you should buy this instead of that one. But you have to learn Chinese, okay? So if you know Chinese, you can buy the same book in color. But it's 10 times cheaper. It's about $10 or something like that. I tell you another joke is that one of my students actually sent me a PDF file of this book and asked me to sign. Cheating. Yes. I say, why don't you buy the real one? It's only $10. He said, I can buy the PDF $2. I say, and it's already very expensive because other books are $1 for 2 copies. Yours is already very expensive, but I still buy it $2. I say, okay. So next time you don't need to send me the real thing. You just send me a PDF. I can sign it for you. I don't earn any money anyway. But this, I think next time you go to China, you should try to find a copy. Very difficult to find now because it's all sold out. But the color version of this guy, but in Chinese, of course. Now, this has always been the fundamental framework. I mean, the first thing you have to collect the information in a map-based format. Everything has to be spatial. You have to tell the climatologist to relay the information in a spatial way. We are not interested in average at all. We are interested in a high resolution, spatial resolution climate information. Once you tell them this is what you need, they can find a way to give you. either by means of data fusion or by means of many stations. Okay, they have a way to do that. But you have to tell them, we are not interested in average at all. We are not interested in the station at the airport at all. Okay, we are interested in spatial data. And high quality spatial data are now possible. Okay, the climatologist has a way to do that. So you don't need to worry about it. And they give you more information than you need, and you have to embed them. And together with all the, what we call the city structure data that you have. Because once you combine the weather data at high spatial resolution to a city structure data at high resolution, then you can immediately see where the solutions are. I don't even need to tell you. Okay? So therefore, information embedding exercise has to involve high resolution data. Then you put it together in such a way that it's easy to access, i.e. on a computer, simultaneously the planner and the climatologist can respectively in their own office access the same data set. And then later on, then they come together to discuss the support system and the decision-making system afterwards. And this part will be made easy if these two are structured in such a way, very easily accessible and very high resolution, being the two important criteria for the data. So in Hong Kong, I think once you have that basic understanding, you then very quickly look at the planning mechanism of the land. In Brazil, I'm quite sure you have different kind of planning mechanism or different way to plan a city. In Hong Kong, we have the strategic plan, which is a long-term plan that lay out the government's or the society's vision of the city in the next 30 or 50 years. So it's a long-term vision kind of strategic plan. You may have something similar, okay, where the city is going, how the city may allocate resources to different parts for what purposes. Those are very fundamental kind of planning decision system that politician makes once every 5 years, 10 years, something like that. And from there, then the planner will take the strategic plan and develop what they call the statutory plan. Plan that means something from a land use point of view. And this is where the density and the building height and the zoning and everything else is defined. And they also have note that you should read together saying if this is how they define it, this is the meaning of that word. So this is the standard, or we call the guidelines. This set of plan is statutory, i.e. they are legal. So everybody has to follow that. So from the strategic vision to this implementation, there are lots of planning decisions that need to be balanced. And environment being only one of them, not all, okay, only one of them. And from that plan, the developer or the neighborhood can then say, okay, in that case, that piece of land will be developed in such a way with the building there and the land and the open space there and the road there and things like that. So this is more what you call the development plan. So in Hong Kong, there are only 3 levels. In Brazil, you may have more levels. It's up to you. Then the next task is to see, okay, at which level and by what resolution your climate data should fit in. So our meteorologists come up with the analyzed plan. Then the planner interprets it into the recommendation plan, i.e. every color has a certain meaning. And this area is here somewhere. Okay, so therefore, based on the understanding, this area needs to be planned in such a way. So that plan is always designed from bigger scale, using a bigger scale understanding of the city, or even larger, before we come to this plan. And then this also gives you what we call the boundary condition for your further studies. So for example, you want to study the temperature or wind profile of this particular site, embedded into that particular area, embedded into this particular city plan, then you need to use those bigger scale understanding to this as a boundary condition to drive your simulation or your study. And this level, the spatial resolution is typically in 200 meter by 200 meter, because you only need to worry about areas. You don't need to worry about right or left side. But in this case, it's about 1 to 2 meters, i.e. the left side of the street is different from the right side of the street. And this map can never give you that information, but then using this map with further downscaling, you can come to that understanding. And those downscaling will be scientific, therefore the downscaling understanding will be scientific. So this is how the weather data or climate data come into affecting different parts of the planning process. And without this understanding, then the planner will try to ignore you at the wrong place. If you show this map to these people here, they will ignore you. Okay, they won't listen because it doesn't give you the information for this understanding. So you have to be very careful at the different scale of understanding. The planning scale for this is 1 to 5,000. The planning scale to that is 1 to 200. This is an example that we demonstrate to the government a long time ago now, when I was still a bit younger, how the map that we create can be used to structure the redevelopment of this area. This area is 300 hectares. It was the old airport. Now the airport is here. But this big chunk of land next to the core of the city that need to be redeveloped. For 10 years, they left it empty because they have no idea how to do it properly. And then we draw up this particular climatic map and showing that if they do it in a certain way, it will not affect the surrounding neighborhood. And it will actually give them some benefits. So when you present this kind of vision to the neighborhood, they won't say no. Otherwise, they will forever give you a hard time. I'm telling you that whatever I do will provide you with further amenities and also goodies. But it will not affect you at all environmentally. So you will still be comfortable, but you have a park to go to next door. So the access to the central park is easy and straightforward from there to there. And also the orientation of the lot is positioned in such a way that they don't block the most important incoming wind. As you can see, this is the runway. The runway always face the wind. That's how they built runway. So the wind always comes from that direction. And therefore, everything else is therefore zones accordingly. And all these lots have their own restriction, like land cover restriction, port ratio restriction, building height restriction. So that the idea is not to affect the surrounding environmentally. And of course, they provide further amenities. The hospital is there, school is there, so the neighborhood will be able to enjoy the new development area. So it's a win-win situation. So when that plan was published, after they argued 10 years, the neighborhood finally agreed that this is the plan. No objection at all. So build it tomorrow, please, that kind of thing. And now, of course, at the end, we also do another level of interventions that this is the area that we will use district cooling for the entire area, because we calculate that with the reduction of anthropogenic heat because of air conditioning, this area will be 1 degree cooler, okay? And 1 degree cooler is important, okay? Don't estimate that 1 degree. And therefore, you can go outdoor 30% more time than otherwise. So all people can then enjoy their outdoor environment better. That kind of thing. You tell them this, they agree. So the district cooling is somewhere here. It will be very expensive. But then the government say, do it, okay, because it benefits the entire neighborhood and beyond. So it's the first time that we make the district cooling cost effective because of that. And this is the ultimate visualization of the entire area. Now, in the past, they always do, if you can see the background here, always connect the tower together and maximize the frontage so the frontal area is high and things like that. But you can see that in this particular plan, that those are not allowed. But on the other hand, the density here is the same as density there, same density. It's just that you design your block in different way. Then the environment is not going to be lower, but the density will remain the same. All to do with site coverage. In the past, before we do this map, the government always told us that if you lower the density in Hong Kong, you have to kiss goodbye to everything. You should not do that. So the density is high. Our port ratio is 8 to 12. Yours is 5, yes? It's a long way to go, okay? So, but then I told the government, you can build 15 if you want, but the ground coverage should be reduced. Once you reduce the ground coverage, you can do more. And in that case, the government then decided that, okay, the ground coverage of those is only about 30%. And then I say, okay, once you do that, then you have to set 30% of the site area as landscaped area, trees, okay? Or 60% grass, okay? But developer being developer always do 30% trees instead of 60% grass, because the other 30% they will use it for shopping mall. Okay, fine, no problem. You still do that, but then you give the neighborhood back the avenue, but then you do whatever you need for your density. So this particular site, the overall density is very high. It's about 7.5. But yet the ground coverage and the tree ratio will dictate the most important environmental condition of the site. Elsewhere, I think we then say, okay, the Central Park should be here somewhere. The hospital, I think, is here. Hotels, schools. There are schools here, something like that. So this becoming the guiding principle on not to form kind of a high frontal area density kind of neighborhood, but more kind of dispersed type, but high-rise kind of neighborhood. This is another, I told you, another area that the government, this is another OZP area. This is a land lot. These are some of the higher density shopping development, things like that. This is the main road, the main river, and next to it are the main roads that goes to the city. So the government say, okay, we will intensify this area from currently this is 5 to 7. Okay, how to do that? Originally, the planners say, okay, just increase the maximum building height allowed from 20 meters to 25 meters. That's it. But then we went in and suddenly we realized that this is the worst way to solve a problem, i.e. do not try to make the city the same, i.e. don't increase all of them at the same time. Try to increase them in different way. Then we give them some simulation. If a city is like this, the same density city, if it's like that, the performance is much higher. Same density, different morphology, different height. But then some building will be taller. You have to accept that. If there are some viewpoint that you need to keep, then you need to put your tall building somewhere else that doesn't impede into your viewpoint. But at the same time, you have to do building in such a way that it is highly inhomogeneous, because only then that you can create different kind of environment inside your city. And people who like one kind of environment will go there, and another kind of environment will go there. So we told the government, I would say, okay, if you want to do that, you have to identify the lot that you can give them 50 meters higher, and other lots that you cannot give them anything. So the government, then there are ways to do that. So based on the map that we allow them to find out a few areas to test out. This is the main one that we talk about, a big piece of land that we can allow. But then if you do that, you have to do something else. You cannot just increase the height and do nothing. So based on this is the area, which is, this is the map, and there are notes saying what you should do and what you should not do where. Okay, this is the note that we put together for the government. Oh, this is, by the way, Ren Chao's PhD thesis. Her PhD thesis basically sets up the planning guidelines for the city for the next 30 years. So therefore, this thesis is embargoed, i.e. nobody can read it. It's locked for 10 years. So until today, I think nobody read her PhD thesis yet. So So it's a PhD, because otherwise people know exactly where to buy their next piece of land. Anyway, it's good for a PhD to do that, yeah? Anyway, so these are not telling you what to do. And then we also tell the government these are the wind conditions and the thermal conditions and topography and the downhill move. There are a lot of hills around it. And they have downhill advantage to different parts of the city. So if you build there, for example, you block the entire downhill. So you affect you here as well. So you say save those downhill and then maximize the sea breeze. And therefore, this particular site that you develop must have a few features incorporated into your plan before you are allowed to develop. So the government then sets up different zones of the same site, saying this zone you can do this, that zone you can do that, there you have to do this, there you have to do something else to compensate your higher density and higher building height that you're going to put in. So this is the way that we give the community the opportunity to build, to densify, and not to affect the environment. This is one example. We have many more of those. And then we actually, in another exercise, try to prevent people from doing this. This has a very high frontal area density, as you can see. So we do calculations to say if your building is this tall, you must have a certain gap between the tower. So that was the whole idea. We called it the permeability ratio. Now, what we have found that by the time your building is tall, say 30, 40 story high, then the two-dimensional way of looking at your building from plan is not going to be very useful for you to divide better regulation. It's the three-dimensionality of how you look at it becoming important. So therefore, the section becoming more important than the plan. So the planner will look at your section as well as looking at your plan. i.e. they look at your ground coverage, but they will also look at your permeability, three-dimensional, vertical ratio, to guarantee that your ground cover is low and your permeability is high, for example, or of a certain percentage. So therefore, when you come to a high-density way of designing city, make sure that you always look at the city three-dimensionally from section point of view. You regulate it using section. You don't just regulate it using plan. That's gone. So from time to time, we come to that. For example, daylight calculation, we used to regulate it horizontally. But now in Hong Kong, we regulate it vertically, okay, taking section into account. And also that the lower part of the city is more important to get right than the upper part of the city, okay? So concentrate 90% of your effort, of your regulation, of your rules at the lower part. For example, in Hong Kong, the lower part of the city is defined as 0 to 30. So, and then we therefore regulate how the podium occupy the site, how the narrow street should be recessed once on development, and how the tower touch the podium at the lower level. So we develop many ways to make sure that at the lower level, 0 to 30, it is much more permeable, much more green, a lot more shading. And up there is not that important. For example, this tower is 50 story and 60 story has absolutely nothing to do with the lower level. It does not help you anymore, or it does not give you any more problem. 50 to 60, something like that. But whereas if you forget to do it properly at the lower 30 meter, then the whole equation is gone, whole battle is lost. And of course, greening is another important thing. In the past, we allow roof greening, but we find out that forget it. Everything has to be on ground. At the 0 to 30 layer, that you put in all your 30%, 50% required. Anything up there, not useful, okay? So we actually develop formulas that they have to do something if they want to build a little bit more. This is the requirement nowadays. So this is an example of how we develop, okay, this is how it looks like, okay? This is the map that we find out there is a problem, that the government is redeveloping this entire area. This is half a kilometer by approximately half a kilometer. So it's quite a large urban site that the government wants to redevelop it. Originally, they tried to put in buildings that look like this. One by one, they line up like soldiers. We say, no, you have to distribute the tower in such a way that they don't form a line. So two are there, and one there, and one there. They don't form a line at all. And the second thing is that the ground coverage has to be low. But then they need to put in a big shopping arcade. I say, easy. This is ground zero. This is 50 meters above ground. So it's like a hill going up, and they come down. So there is no sharp edge. So actually, the wind blows from this street into the site, across up the hill, and down the hill. That's all. So everything is underneath. So you give the ground back to people, and do not form vertical wall. And then there is another one that comes down here. You can see. So this is the reason why these two towers has to be on both sides. And this one will go to the sea, you can see. So there are axes that allow things to move through, and the towers are not connected, and the towers are raised from the ground, from the podium. So if the podium here is 20, the towers start from 26. So there are ground underneath the tower that are shaded and are perforated. So this is the idea of our suggestion to them. Originally, they built it like this. You can see. This is the old way of designing. But now we say with the new understanding, this is the way to do it. And the ground coverage is very low. But then because everything is underneath, so the ground is now everywhere. And of course, Hong Kong people are very lazy sometimes, so they have some escalator to go up 5-story and go down 5-story. Things like that. So this is now on site, and in 2 years' time, it will finish. So next time you go to Hong Kong, please visit this site. And if you like it, send me a postcard. And in Singapore, we also did a map for them. As I told you, that's their urban area should be red in color. Now it's pink, of course. Some problem area, which is this area here. So the government is very proactive. They then say, okay, what should we do? In Singapore, the problem is they have no wind because they are on the equator, so they have no wind. So wind cannot solve their problem. The only way to solve their problem is greening and shading. That's all. So they say, okay, in that case, you try to find a way to maximize your greening. In Hong Kong, it's 30%. It's up to you to define anything more than that. They say, well, in that case, in Hong Kong, it's 30%. We'll do 100%. Better than you in Hong Kong. Okay, fine. So how do you do that? They say, okay, in that case, if your site area is this, then you have to put in as much, all the greening that your site has lost in different parts of the tower. So you put 30% here, you put 30% there, 30% there, 10% there. So you put back 100% of greening onto your building. After they set up the law, I told them that actually they have misunderstood my recommendation. It should be 100% of all the surface area of the site, not just the ground level of the site. I.e., your building has a lot more vertical surfaces. These are surfaces. So you have to cover your entire building in green to qualify 100%. They actually did one building. The entire building is covered by Wuha. Okay. Next time you go and have a look, it's quite interesting. The entire building is vegetated. Then I told my architecture student, I say, next time that you forgot to draw or design your elevation, it's easy, just cover it in tree. And your tutor cannot comment or cannot give you a hard time because they cannot say tree is not beautiful, yes? Okay, and they cannot say tree is no good because it's all tree. So nowadays, my students don't need to do elevation anymore. All trees. This is one example that they put in, but then I told them that this area also has to be green. And also that I told them that actually, if your trees are like umbrellas, it's much better than if they are straight. And so therefore, this particular avenue were fully covered by trees all the time. And nowadays, the government of Singapore use that as a slogan. They say not garden city, but city in a garden, the other way around, to celebrate their achievement. It's very good. So architect can use this kind of climatology information for the aesthetic and also planning advantage. How long do I have? Am I running out of time? Are you bored? No, not bored yet. How many of you want to sleep? Okay. If you sleep, can you please make as little noise as possible? Otherwise, carry on. This is Taiwan that we did another. Taiwan is again a tropical city, hot in the summer and not very cold in the winter. So we again lay out all the information. We then combine those information into a climate analysis. And we identify a few areas that may require certain help. And there are some area that has a lot of goodies. And since wind direction is from that area, from the east, from the west, we told them actually that you should find a way to benefit this guy. Now, without this kind of map, you cannot use something that is 5 kilometers away to help you. There's no planning mechanism that you do that. But with the map, you know that little bit of landscape area assisted by the sea wind can help you 5 kilometers away from you, provided that you do something. Okay? So the government was very keen that in order to solve this area, they need to do something here. This is the area that they must maximize their effort. The other areas are okay, so no problem. So they don't need to worry too much about it. But however, we told them that actually your city can be defined climatically into 10 zones. Each one of them, the name of the sub-area is there, have different kind of needs for attention. Do this, don't do that. Two star means important, okay? Do more of those. One means good, but not that important. So the government then different government can then tick different boxes because they are in different area. So their helps come from different, for example, this area, the help come from the annual wind. This area, the help come from the sea breezes, okay, i.e. nighttime, okay. You must find a way to, you flush the city at night with cool air. Then in the daytime, first thing in the morning is better. Things like that. There are different helps. So, and there are different techniques. And we told them that fundamentally to improve the city, there are only 3 techniques. Only 3, no more. Wind, which flow in a certain manner in your city, and your building engage the wind in different way, and do that, don't do that, and things like that. Water, the water body is again something. If you have water body, keep it at all costs. Fill it with water, okay? Don't let it dry, but so that they channel the goodies to other parts of the city much quicker than anything else because the water has very low friction. So therefore, these hills are there. The city therefore need to maximize this kind of hill-water dialogue between the two. Okay, so water. Third thing is of course green. Okay, 3 things: wind, water, green. That's it. And your building has to somehow find ways to maximize how these 3 things come together. Now, it's no point to have these 3 things isolated. It's very important to connect them. So the whole idea of the city planning is to try to connect these 3 things from one area to another one, so that they can benefit each other, they can flow, the element can flow. So connectivity is more important than the open space itself, okay? So that has been another advice that we give to the government. So all the time we draw lines because these elements flow via those lines. Okay, so we say, okay, in green, you have to do that. Some of the area, if you want to benefit this, you need to pedestrian line 1 or 2 streets and plant trees, let the cool air continue. This is the artistic rendering of the city in the future that the mayor then try to sell to the citizens. Say, my city is going to be like this if I were to be re-elected. Oh, she was re-elected, okay? This is the hill, this is the sea, These are all the goodies that this hill will bring down. So some of these are vegetated. And then coming to this particular piece of land, I say, don't do much here, make it into an open park. You can build your building somewhere else, but because this is the beginning of your city. And try to line this up if you can. So this guy will then flow through. And then you can still develop a lot if you want. There, not there. And they follow the idea, and then now it's becoming Kaohsiung's next master plan for the next 30 years, I hope. In between, they'll change a few things, but the fundamental principles are there. This is Macau. Macau is a very small piece of land. They have a city there. And then they try to enlarge the city by reclamation. They try to put a piece of land there. They asked me, should I do that? So I said, okay, let's look at your climatic map, which is like this. Then your city has three parts. This is the nice part, this is the developing part, and this is your problematic part. If you put something there, and since your wind comes from the east, then you're going to have a lot of problem. Can you put it somewhere else? I said, how? I said, can you do that? Can you put it here? But then put a small one there because you really need something. But don't touch this water body. Put your land a little bit away from your main city, which is here. Then the ill effect of this piece of land, since it's very narrow, not a bump, not a lump if you put them together, will affect your main peninsula less. So we did a very complicated fluid dynamics understanding, say how far this needs to be in order that this piece of land is not affecting the circulation of that piece of existing land. Because if you put them very far away, A, is very expensive, B, is very difficult to connect it back. So the government is going to give you a lot of trouble. The engineer will say, oh, it's too expensive, cannot do it. And then that's it, you're dead. But then if you can show them the optimum distance away from your mainland, this one, then so we control two things. One is the distance between these two, and the second one is the length, is the depth of this land. You say, try not to bump it there. Try to do it like this. So, and of course, in that case, they have to build a few more bridges, but then you justify it. So we did a lot of study. This is the study that a German researcher, Sigi, in Hannover, helped us. And this is the world's largest LES. How many of you use fluid dynamics? Okay, anyway, yeah, LES simulation. You know LES eats up your computer in no time at all. This is a 6 billion grid LES. Yeah, it's the world's largest LES simulation. And then we asked the German government to help. It's very good. The German government say, how big a computer you want? Then we specify a computer that we want. And they actually bought it. I think it's 30 million euro, something like that. Yeah. Just to do this. And they say, why you have to do that? It shows German technology is world leading. Okay, fine, thank you. Yeah. So currently, we are actually giving them another problem because it's time for them to buy a new one. So we set up another simulation, 60 billion grid for them. I say, this is the simulation we want to do tomorrow. They're buying a new computer, another 30 million or 30 or something like that. The Germany people are very rich. If you give them a hard enough task, they will do it for you, free of charge. So they're doing a lot of simulation for us, free of charge, and it's very good. But anyway, this is some of the understanding. This is the problem of that area generated. You can see that it will stop somewhere there like that. So therefore, we define that distance. And that distance, there will be no building, so the ill effect will only stop there. Something like that. So we showed it to the neighborhood, to the community. And immediately, most of the people in the community stopped complaining and opposing this scheme. Because we also told them that this area will have no building, it will become your promenade. It will be a park for you, okay? And this building is not affecting you, and this area, it will be a park. So they're very happy. So sometimes this kind of simulation, although very scientific, but when you communicate to the old lady living there, you have to tell them that in no time at all, you will be able to enjoy the seafront and the promenade with a good shaded area for you to sit. And they will be very happy. And we also set up a few guidelines for them when they try to redevelop. This one I don't want to go into. So all the time from the WCC3 paper to the city, we're finding ways to communicate between the two groups. And if you have to find a way to do that, then you may wish to talk to your meteorology department so that some of them could be interested to become your team. Then your voice will be louder because it's more scientific. But then you have to translate it so that the old lady understands. So this is a very friendly advice that we have to make sure that what we understand become real. And what I told you just now is how I somehow find ways to make it real. This is my team. These are all the people who work with me, for me, and then together. I'm here, of course, as you can see, the oldest, the wisest. This is the lady who has changed the world at the moment, because we have changed a little bit of Hong Kong. She's now changing the entire China. She published the guideline for China government, and now all 296 cities in China must follow this law. This law, yeah. So she was the one behind. So she's now very famous, more famous than me. But I'm very happy that my student can be better than me. So whatever we have done, we are only starting to do it. But I'm quite sure our second generation, you guys, is going to change the world. Change Brazil to start with, okay? Brazil is bigger than China, I've been told, yeah? Land area, similar. So, okay, so if we change Brazil, it's as same as her changing China. So it's the same problem. Okay. This was the original title, which include climate change, but today I didn't. So my last slide is always something that I want to, this is my last slide. So thank you.